Welcome, advanced developers. Today we are tackling a crucial problem in RG systems, bridging the gap between natural language intent and structured metadata filters using self-querying retrievers. Let's get started. When building retrieval-augmented generation systems, we often rely entirely on semantic similarity to find relevant documents. But users do not just search by abstract concepts, they search by hard constraints. If someone asks for a science fiction film released after 2020, standard semantic search struggles to understand after 2020 as a strict numerical filter. This is where self-querying retrievers come in. They sit in front of your vector database and use a large language model to interpret the user's natural language. The LLM acts as a translator, separating the conceptual part of the query from the structured metadata filters. This allows us to perform a highly accurate, dual-layered search, applying hard filters first and then running semantic similarity on the remaining documents. Looking at this flowchart, we see the user's query entering the system and hitting the LLM translator first. Instead of passing the raw text directly to the database, the LLM splits the request into two distinct streams. On the left, we have a pure semantic query representing the core meaning, and on the right, a structured metadata filter representing strict conditions. Both streams feed into the vector store concurrently to retrieve the perfect set of documents. Why go through the trouble of translating natural language into filters? Because embeddings are excellent at capturing abstract meaning, but terrible at discrete logic. If your user asks for hotels in a specific town under $100, an embedding model maps this to a concept in high-dimensional space. However, your database holds explicit, structured metadata for location and price. Without translation, the vector store might return a $300 hotel simply because its textual description is semantically similar to your prompt. By explicitly translating the natural language into metadata filters, we enforce strict boundaries, telling the database to first drop any hotel over $100 and then find the ones that match the conceptual vibe. This process guarantees accuracy and eliminates hallucinated retrievals. Here we contrast the two main retrieval paradigms. On the top path, semantic space is fluid and conceptual, relying on vector proximity. On the bottom path, structured filters use Boolean logic like and, or, and exact value matching. The self-querying retriever acts as the critical bridge connecting these two distinct paradigms, giving our applications the ability to utilize both simultaneously. So how does this translation actually work under the hood? It is a multi-step process known as query construction. First, we must provide the LLM with a detailed description of our database schema. When the user asks a question, we send a query generation prompt to the LLM. The LLM acts as an expert parser, extracting the semantic search term and constructing a structured logical filter tree from the output. Finally, because every vector database has its own specific filtering syntax, LangChain uses a translator component to convert that generic logical tree into the exact syntax required by your specific vector store backend. Once translated, it issues a similarity search against the vector store, filtered to only match documents whose metadata passes the generated filter. This sequence diagram illustrates the step-by-step query construction flow. The user sends input to the LLM query constructor. Using the provided schema, the LLM splits the request and sends the structured logic object to the syntax translator. The translator converts it into database-specific code, which is finally executed against the vector store to return precise results. To make this translation flawless, the LLM must completely understand your data structure. We achieve this using LangChain's attribute info class. For every piece of metadata attached to your documents, you define an attribute info object. You must provide the exact field name, its data type like integer, float, or string, and a highly descriptive explanation of what that field represents. For example, if you have a rating field, you must explain that it is a 1 to 10 rating for a movie. You also provide a document description, giving a brief summary of the overarching content. The LLM uses these descriptions as strict prompt constraints. If your descriptions are vague, the LLM will fail to map the user's natural language to the correct fields. Precision in your schema design here is everything. Observe how multiple attribute info objects form an array within the overall document schema definition. This schema structure is directly injected into the LLM prompt. The LLM combines this robust schema definition with the user query to perform the highly accurate mapping and extraction process. Let's look at the actual code implementation. First, you import self-query retriever and attribute info. You define your fields as an array of attribute info objects, detailing things like genre, year, and director. You also need a brief document description string explaining what the documents contain. The magic happens in a single line of Python code. You instantiate the retriever by calling self-query-retriever.from LLM, passing in your LLM, your vector database, the document description, and the fields array. Once instantiated, you simply call the invoke method with a natural language query like, what is a highly rated sci-fi film released after 1990? LangChain automatically handles the entire prompt generation, LLM parsing, syntax translation, and vector store retrieval lifecycle behind the scenes. This diagram maps our code architecture. We define our attribute info fields and a document description. These feed directly into the from LLM initialization method alongside our LLM and vector database instances. The resulting object is our fully functional self-query retriever, ready to process invocations and return final filtered documents. Let's apply this to a real-time, highly valuable use case, an enterprise UK travel destination platform. Imagine you have thousands of travel guides indexed in a vector store. A user asks, tell me about events or festivals in the UK town of Newquay. A standard semantic search might get confused by the generic word events and return festivals from London or Edinburgh. By implementing a self-querying retriever, we define destination and region as explicit metadata attributes. The LLM translates the user's natural language, extracting Newquay and applying a strict equality filter, destination equals Newquay. The database drops all documents outside of Newquay before running the semantic search for events or festivals. This guarantees zero geographic hallucinations and ensures a perfectly relevant user experience. Here we see the travel query state flowing through the system. The natural language hits the metadata extraction state where the LLM identifies Newquay. It then transitions to the filter applied state, discarding irrelevant geographic data. Finally, semantic search is applied exclusively to the Newquay documents, yielding highly accurate and targeted results. To conclude, it is important to understand how LangChain executes the final database query. Because every vector database utilizes a slightly different query language, LangChain leverages native translator classes. When you initialize the retriever, it automatically detects your vector store and assigns the correct translator like Chroma translator to convert the LLM's abstract structured query into executable database code. In JavaScript environments, you can explicitly pass a structured query translator like functional translator. This brilliant design makes your application completely database agnostic. You can swap your backend database tomorrow, and your natural language translation will still work perfectly. Master this pattern, and you master enterprise-grade retrieval. Be sure to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram illustrates this database agnosticism. The LLM structured query sits at the top. Depending on your backend infrastructure, the translator engine routes the logic to the appropriate syntax generator automatically. This translation layer completely decouples your application logic from database specifics, ensuring long-term maintainability.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechit.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.